All right, so we are starting Unit 7, Investigating Data. So a scientist studied the relationship between the number of trees, X, per acre, and the number of birds, or Y, per acre in a neighborhood. She modeled the relationship with a scatter plot and used this equation here, Y equals 4 plus 6X, for the regression line. What is the meaning of the slope and the y-intercept of this regression line? Well, let's first figure out what is our slope. Well, y equals 4 plus 6x. Our slope is 6, in case you've forgotten about that. Our formula sheet here has the slope formula, and it tells you that's m. And then our equation in slope-intercept form right here says y equals mx plus b. So mx, that's our slope with x, and then b is the constant by itself. So our slope is going to be the 6. So the slope is 6. Slope is 4. That's not correct. Slope is 6. Slope is 4. That's not correct. So we can already eliminate 2 answers. All right, then we know our y-intercept is 4. And both of these have that in here. The y-intercept is 4. And the y-intercept is 4. So now we need to read all these extra words in between and figure out what does the slope and the y-intercept mean. So remember, slope is a rate of change, okay? Slope is a rate of change, so it's telling us about how our birds and our trees are changing within this, this area. So the intercept, okay, and our y-intercept would be the beginning, okay, or the starting point, that the average, how many birds there are, excuse me, when there are no trees, all right? So at 0, okay, when x is 0, no trees, what would we have? Okay, so the slope means that the average number of birds per acre in an area with no trees is 6. Well, our slope is 6, but that's the number 6 over 1, not 6 over 0. So this is not correct. The third one here says every 1 additional tree, she can expect 6 birds. That's 6 over 1. Birds was our y and trees was our x, so 6 over 1. Our y-intercept is 4, and this means that the average number of birds per acre in the area with 0 trees or no trees is 4. And that, that is our solution. All right, so our next question, Kendra and Theo each collected data on the number of birds they observed at a bird feeder for each hour for 8 hours. The data Kendra collected is summarized below. The range of Kendra's data is 6, the median of Kendra's data is 7, and the mean of Kendra's data is 7. The data Theo collected could have the same range, or has the same range and the same median as Kendra, but the mean of Theo's data is 7.5. All right, so let's see what we need. So we're going to use Kendra's range, and we're going to use Kendra's median, but we're not going to use Kendra's mean. We're going to use Theo's mean. So down here, we've got Theo's information on a box plot. So I actually put the graphing tool up here and moved it over a little bit. So let's put in first our list. So our list is 2 5s, so 5, 5, 2 6s, an 8, and a 10. So that's what we have so far. We've got 6 elements, so that's what it told us. We had 6. So let's do our 5-number summary of those points. And we find out here that our minimum is 5, our maximum is 10. All right, so that makes our range only 5. We've got a median of 6. And this doesn't show our mean, so we're going to also need to put on here the mean. So let's type in the mean of L. Let's see what Theo's mean right now is 6.666. So we need to raise the range, and we need to raise the median, and we need to raise the mean. So we need to put numbers that are higher than the numbers we have so already, or the numbers that are higher on the higher side instead of the lower side. So we're going to start off, or I'm going to start off. I'm going to put in a number. Let's try 11. So what does 11 do? 11 expands my range. So now I'm going from 5 up to 11 for my range. So that gives me that range of 6. Okay. But I'm missing still. I still don't have the right median, and I don't have the right mean. So my median and my mean are still too low. Well, what if I put in another 11? So now my median is 7 and my mean is 7.75. That's too high. So let's try with a 10. With a 10, my median is 7 and my mean is 7.625. That's still too high. So let's get rid of that 10 and let's try a 9. So our range is from 5 to 11. So that's 6. That's correct. Our median should be 7, just like Kendra's. That's correct. And our mean is 7.5. So we found our two numbers. So the two numbers we need to add in are 11 and 9. So they're right here. So we're going to come over to the box plot, and all we have to do is click on 9 and click on 11, and we have created our box plot. All right, our next question here, which set of data points could best be modeled by a line of best fit that is decreasing, that is a decreasing linear function? So the two things we need to see here are decreasing linear function and the word best be modeled. All right, so we're going to again use our graphing calculator tool. And we're going to work on that line of regression. So I'm going to put a table in. So I'll start with my points. All of my points have 0, 1, 2, 3, and 4. So my first set of points, 0, 0, 1, 8, 2, 15, 3, 22, and 4, 30. Well, if we zoom out here, we can see that one is increasing. That is off the list. All right, so that's not our answer. Let's try the next set. The next one is 0, 5, 1, 6, 2, 10, 3, 16, and 4, 28. All right, that one doesn't even look linear, but it's definitely going up. So that one is also not correct. We don't need it anymore. So 0, 50, 1, 42, 2, 33, 3, 25, and 4, 16. Now that right there looks like a pretty good line. So that one's a contender. I'm not going to get rid of that one. I'm going to keep it. So let's put another table and let's look at this last one and see what does it look like. So 0, 64, 1, 60, 2, 52, 3, 39, and 4, 22. All right, so let's turn off the green one for a minute so we can see the blue one. So now the blue one doesn't look like as good of a line. We can see there's kind of like up top, there's maybe a little bit more displacement, but let's make sure. And how can we make sure? Well, here to our green one, I'm going to do a line of regression. So y sub 1, and then remember it's mx1 plus b. So that shows me my green line. And remember what we're looking for here is how good is this r value. So my r here is almost -1. That's a pretty good r. Our second function, now notice this, it had x2 and y2, so we're going to need to use y2 and x2 when we do this one. All right, so this time my line of regression gives me about -0.97. So which one of those is closer to 1? Well, that would be our first one. So this first line is going to give us the best line of regression that is decreasing linear function. So that's the one we're going to choose. right? And this problem just asks us which set of data could be best modeled by a quadratic function. So remember, a quadratic function is that U-shaped graph, or that U-shaped graph flipped upside down. It's just that parabola. All right, so this first one looks like it would be linear. I don't think it'll let me highlight in there. It would be linear. Oops. The second one, kind of, I would say there's no correlation there. It's kind of scatterbrained all over the place. C, that looks like it's got a U shape. And then D is going to be a negative linear. So C is going to be our answer here, just that parabola shape, that quadratic. Alrighty, so this one asks us, the number of customers that visited a store on a certain number of hours after the store opened at 8 a.m. are shown in the table. First part A asks us to plot the points. So let's plot the points. All right, we have a point at 1, 2. Got to click the point. A point at 1, 2. Our next point is at 3:15. So at 3:15, it's going to be right between 14 and 16. So right there. Our 4:18. So we're going to come over to 4 and go up to 18. And then 6:13, so 6:13 will be right between 12 and 14. And then 9:0, 9:0. So what kind of graph would we think describes that data? Part B says which statement best describes the data. It can be modeled as a linear function. That's not a line. So that's a no. It can be modeled by a constant function. So a constant function would be a horizontal line. That's a no. A quadratic function, that is our answer. An exponential, remember, would have to have that just curve that goes up forever or one that goes down forever. So our data here would be modeled by a quadratic function. This would be a negative quadratic, but still a quadratic.